All right. Chapter 15 and 16 are probability. A state's license plate starts with a digit other than 0, followed by 3 capital letters, followed by 3 digits. How many different license plates are possible? Kind of a weird question, huh? So a state's license plate is a digit other than 0, so like 7, and then 3 capital letters, so TVP, and then 3 digits, 365. That might be a license plate. That's the way they used to do old California. I had an old 280Z back when I was in college. And that was my I think TVP 365. That sounds familiar. I don't remember what the first digit was. It was something like that. So, get the idea? So that's one. That's the way. Now California license plates have a couple more digits in them, don't they? They're a little longer.
There's 7.
No, there's 7.
Are they?
Yeah.
Oh, okay. All right. So how many are possible? How many different license plates are possible? That seems like a weird and difficult question, doesn't it? It's actually not that hard. Basically, think with me this way for a minute. What if I said, hey, I'm getting dressed in the morning. I have 3 different pair of pants, and I have 5 different shirts I can wear. How many different outfits can I wear?
15.
Yeah, you just multiply them, huh? Right? You just take 3 times 5, 15. Right? Because each of those pair of pants can go with the 5 shirts. I can wear the first pair of pants with any of the 5 shirts, the second with any of the 5, and the third with any of the 5. 5, 5, 5, 15. 3 times 5. You just multiply them, huh? So you guys with me? Whenever you have 3 options and 5 options, multiply them, you get the total number of options. Well, that's what's going on with the license plate thing. It's just decisions, options. So let me encourage you to think that way, and it'll make it pretty easy. So you just go down and you say, all right, I just picked one license plate, didn't I? I picked a digit, 3 letters, and 3 more digits at the back. Think back for each of those decisions, and I made 7 decisions, didn't I? For each of those decisions, how many options did I have? Like getting dressed. I have 3 pair of pants and 5 shirts. My options. So for my first digit, I chose a 7. Now, suppose I picked a license plate there. How many options did I have for that first digit?
9.
Good job. 9, not 10, because remember they said the first one can't be 0? Somewhere they said that, didn't they?
0 to 9.
There it is. Yeah. It starts with a digit other than 0. So you can't use 0. You can only use 1 through 9. We can use a 0 in the back, but the first one has to be 1 through 9. So there's 9 options times. Remember, you multiply these together like the pants and the shirt. 3 times 5. Okay. When I chose a letter, I got to choose 3 letters now. For each letter, how many options do I have? How many letters are there? 26. 26 letters in the alphabet. 26 times 26 times 26. All right, there's 26 options for the first letter, 26 options for the second, 26 options for the third. Then I chose a digit. Now, here I'm allowed to choose 0 or any other digit. So how many digits are actually possible? 10 now, huh? Because 1 through 9 and 0. These are all multiplied together, 10 and 10. Did you use your calculator? I did not bring mine. I should have. Multiply those all together, and we'll get an answer. Here, I'm going to go grab my calculator. You want to start on part B? How many license plates start with an 8 and end with a 1? So I got a big number for that last answer. 158,184,000. What is that? Can you say that number?
158
Million. 184,000, yeah? They got to have enough to cover all the cars. You understand their plan for license plates has to be enough to cover the different number of cars that'll be in California. I don't know how many cars are in California. But you understand if they made a plan that wouldn't give enough options, that would be a problem.
So why didn't they give your license plate back?
What's that?
Is that why they make you give your license plates back? Like if you get a different color?
Oh, I guess so, huh? Because somebody's got to be like a unique ID, I guess. Yeah. All right, so anyway, how about part B on that one? How many different license plates start with an 8 and end with a 1? Let me encourage you. I took a whole class on this, and one thing I learned to do is make it real. That was the best thing. Once I started making these things real, it helped a lot. So when I say make it real, do it. Actually do it. What do I mean do it? I'm gonna come down here and do part B, and I'm gonna actually pick a license plate that starts with an 8, ends with a 1. Here we go. I'm gonna pick one. So I got to start with an 8. No options there. And then I'm gonna do 3 letters, right? So how about WXM or whatever? Who cares? I got to end with a 1, so I can pick anything I want. 7, 2, and then 1. So I just made one up, right? Following their instructions. That is super helpful to do. I really, really, really encourage you. Don't skip that step. It'll totally get you thinking the right way. Just actually do what they're saying one time. Pick a license plate that fits whatever their conditions are, and then think back to what you just did. Think back to the decisions you made and how many options you had as you made each of those decisions. So as I went right here and I chose an 8, that was my first decision, right? How many options did I have? 1, exactly. I only had 1 option. I had to put an 8. There was no other choice. They told me I had to put an 8. See how that's got to be a 1? We're going to multiply these together, right? 1. Next decision, I chose a W. How many options? 26, just normal. And the X, 26. And the M, 26. Next, I chose a 7. How many options did I have there? 10, right? Because I could have put any digit, 1 through 9 or 0. Next decision, 2, 10 options. And then the 1 at the back, when I chose a 1 to go at the end, how many options? 1, I had to. They told me you have to. So there you go. So it just makes those 2 spots into 1s, doesn't it? Just makes you have only 1 option in those 2 spots. So multiply that together. It's going to be a lot lower than the last one was. I'm getting 1,757,600. 1,757,600. A lot less, huh? This had 158 million. That limits your options quite a bit. That might not be enough to cover the cars. So there you go. So that we got to do part C, huh? So let's go on. Is that good so far? Parts A and B. Try C. Try C. And actually do it. Really, really do it. Actually make one up that has no repeated symbols. All the digits and all the letters are different. Now, it's part C has nothing to do with part B. You don't have to go back to part B and go, oh, and I got to do the A. No. Part B's done. Part B's over. Part C has nothing to do with the 8 and the 1. Just pick a license plate that says part C. Pick any numbers and letters you want, but don't repeat anything. So actually do it. Write one out where you don't repeat anything. And then think back after you're done to the various decisions you made, and as you made that decision, how many options you had. Just multiply those all together. Okay, so for part C, so I'm going to actually, no repeated symbols. Okay, so here we go. 3 A D W 765. All right, so I picked a license plate that had no repeating. So let's think about what I just did. I made 7 decisions. Okay. For my first decision, in which I chose a 3, how many options did I have for what was going to go in that first spot? 10, right? Any 1 through. Oh no, you can't use the. Oh, this still applies. By the way, this is above A, B, and C, so it does apply, right? Hope you didn't confuse me. I said B doesn't apply because C is not a subset of B, but they're all a subset of the original instructions, aren't they? Everybody see that? So the original instructions apply to them all, and that is no 0 in the beginning. So 9 options there, right? Everybody good? Everybody good with that? That's how the questions on the exam go too. Does everybody see that? B and C are not related, but they all relate to the top instructions. Okay, 9 options. Next I chose an A. How many options did I have when I chose A?
26.
Well, 26. Yeah, there's 26 letters in the alphabet. Okay, next I chose D. Very good, 25. I could have chosen anything but not D. Because D had already been chosen. I cannot repeat. So I only had 25 options at that point, right? I didn't really have 26 options. I was not free to choose D because I could not repeat. Everybody see that? Next, I chose W. How many options? 24, because I was not free to choose A nor D. I only had 24 letters left to choose from, right? Next, I chose the 7. How many options? 9. Very good. Because there's 0 and 1 through 9, which is 10. You can choose the 0 now, right? Because the 0 just couldn't be in the first spot. Starts with something other than 0. So I could choose all 10, but I can't choose whatever digit I chose there. Because I can't repeat anything, numbers or letters. So I've already chosen one digit. I'm not free to choose the 3 again. I can choose any of the other 9 digits, right? Next, I chose the 6. How many options? 8. Because there's 2 digits, 3 and 7, have already been chosen. I'm not allowed to repeat them. There's 8 other digits that are options for me. Finally, the 5, 7 options, right? So basically, when you can't repeat, it just goes down by 1 every time, doesn't it? So multiply that together on your calculator or by hand. I'm just kidding. I'm sure you don't want to multiply that by hand. 25, 24. And I'm getting some big number. 707, 61600, 70,761,600. There we go. Is that making sense? Decisions, options. All right. Set of reference books consists of 6 volumes numbered 1 through 6. Question 8. The number of ways the books can be arranged on a shelf. So you got this reference book, right? So one of them is number, you're going to arrange the 6 books on a shelf. 4, 5, 6. And you could say, I'm going to put 5 here and 3 there and 6 here and 2 here and 1 here and 4 there. That's one way of arranging the 6. That's all out of order, right? And they're wondering how many different ways are there to arrange those 6 books on the shelf? How many different ways? Let me encourage you. If you feel like, I have no idea, do it. Actually, do what? Do an arrangement. Pick an arrangement. Like I just picked an arrangement, right? I decided to put book 5 first. Then I decided to put book 3. And then I decided book 6. And, on down the line. I just picked an arrangement. And they're asking me how many different arrangements are possible. So I just did one. Remember, that's always my advice on these. Just do one. And then think back. So think back to what I just did. And for every decision I made, write how many options. So when I made this first decision, how many options? Next decision, how many options? 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 And just multiply those together. Think about that for a second. So for my first decision, I chose to put reference book number 5 in the front. How many options did I have there? 6 different options. I could have put any of the 6 books in the front, huh? I happened to choose book number 5. Okay, times. Next, I chose to put book number 3. How many options did I have at that point? 5, right? There were 5 books left to choose from for who goes next, right? Because the other one book was in place. There were 5 other books to choose from. And then 4 books, 3 books. You get it, right? Is that too quick? You okay with that? There's always one less option each time for which book comes next. What does that look like? Have we seen something like that before? Remember that? That's that, huh? That's the factorial where you multiply on down to 1. So just multiply that, and you just do it by, you don't have to use that button. It's fine just to do it that way. 720 ways. 720 ways to arrange 6 books on a shelf. Would you have guessed it's that many? 720, almost 1,000 different ways to arrange 6 books on a shelf. That's why when they make combination locks with just 4 or 5 numbers, there's actually a lot of possible options. It's not easy to break those codes. That's the kind of thing they figure out when they do locks and security codes. Banking does this with the way they do security codes and things. They got to have a lot of options so that people with computers can't just break it down. Is that good so far? Let's try part B there. In how many ways can the 6 books be arranged on a shelf so that at least one book is out of order? So that at least one book is out of order.
At least, so all of them are out of order.
Or just 2 of them, or 3 of them. Question B is the easiest question in the world. It's not the easiest in the world. That's dramatic. It's a super easy question that's hard to see. In some sense, it's not easy. But I mean, if somebody shows you the right way to look at question B, it's just like, oh yeah. But if you don't look at it the right way, I have no idea. What a crazy question. I told you I took a whole class on this when I was at Cal Poly getting my math degree. The class, I did a whole 10-week, we did quarters at Poly, 10-week quarter on all these kind of problems. It was after calculus. It was a junior level math major class. And the title of the class was called Counting. Doesn't that sound great? I remember when I signed up for it, counting. All right, this will be a snap, right? I took counting. It was so hard. I mean, this is just the beginning. They get hard. This is a subtle subject. The differences are small and they're hard to distinguish. It was so hard. I remember I had Dr. Hood. I had him for so many classes. He was hilarious. I think I mentioned him before, right? He gave me the 42 on the exam, and he always was bent over his old then. You guys did. He's always telling us we're stupid. And I remember I had him for that class. And so we get near the final, and he this is how hard it was. He gave us the final ahead of time. Literally. No change. Gave it to us. 20 questions. Double the number. He gave us like 20, 25, I can't remember, something like that. He said, these questions, half of these, no changes at all, half of these will be your final in a week. Get together with your friends, figure these out. You got a week. Half of these will be the final next week. That didn't help. I mean, I didn't know how to do them. My friends didn't know how to do them. Nobody knew how to do those problems. I mean, I'm sure somebody knows how to do them, but none of us could figure out how to do those problems. I mean, I didn't get an A in that class. That class was hard. I mean, they hand you the final ahead of time and you can't do it? It was hard. It was very subtle. But what was interesting to me, it was still intrigued to me. I liked that class. What I liked about it was the way you could take a super confusing question, like part B. Part B. Just, doesn't it sound crazy? Probably, I'm assuming it sounds pretty crazy. Does anybody have an idea? You have an idea? Yeah.
Well, there's only one way they can all be in order, so we can just pick one out. 77, 19.
Beautiful. Excellent thought. It's exactly right. She's reading the question and grabbing it well. Very well done. I'm impressed. I don't think anybody in Math 45 has ever nailed that one. I'm very impressed with you. You just went up in my charts there. Mathematically, I'm very impressed with you. Yes. Right. Hear what she's saying? Let me bring everybody to that point. What are they saying? In how many ways can the 6 books be arranged on a shelf so that at least one is out of order? Now, what are we talking about? At least one. You got to really get what they're saying. Think about it. If I put the books on the shelf like this order, is at least one book out of order? Well, yeah, lots of books are out of order. What would it mean? A lot of times what you do on these questions is you ask the opposite question. And you say, what would it mean if it was not the case that at least one book was out of order? What if I put them on the shelf and my wife said from the other room, hey, honey, is at least one book out of order? That'd be a weird way to talk. But anyway, and I said, no. What would that mean? No, at least one book is not out of order. They're all in order, right? If there's not even one book out of order, then they're all in order. They're 1, and then 2, and then 3, and then 4, and then 5, and then 6, right? That's the only way there's no book out of order, right? How many ways are there to put them so there's not even one book out of order? Well, there's one way, that way. The right order, right? Any other mixing, if you said, well, I'm just gonna put the 6 right there. Everything else is good. 2 there, I guess. Well, then that's out of order. At least one book is out of order, right? Any messing with the one true order is at least one book out of order. So when they say, remember there's 720 total different ways to rearrange the books, but only one of them has all the books in order. So if they're saying, how many ways that have at least one? Well, all the ways but the one. So take 1 away, obviously, 719. Once you look at it that way, you're like, what a simple question. But until you see that, you're just banging your head on the wall, and I spent many hours banging my head on the wall on lots of questions in that class. But every now and then, Dr. Hood would say, you're so dumb, da-da-da-da-da. And I'd go, oh, yeah. Why can't I see it like crazy Dr. Hood sees it? Yeah. So, yeah, that's good job. Very All right, so yeah, this is going to be, we are 5 minutes, good. So you guys have your calculators? We got to do the P and C thing. Do you have your calculators today? Maybe it'd be better if I went on to something else and say, don't forget, well, I'll show you the by hand. Yeah, so, okay, these are all P's and C's. So first off, this has no real life significance yet. It will in a minute, not a minute, it will on Thursday or next week or whatever. We'll talk about what in the real world this has to do with. But for now, let's just learn how to crank out the formula. 13P2 stands for permute. What it means, or I'm not going to tell you what it means. Here's how you crank it out. You take the first number and you multiply two numbers going down. So 13 times 12. And that's it. Whatever that equals. So I guess it's not that hard. We don't need the calculator thing, huh? Maybe I'm being kind of dramatic. 156. That's the answer. So, in other words, you start at this number, and this is the number of numbers.
When you go to 11? Yeah, no, what did you go to 11?
No, two numbers total, 13 and 12. I don't mean you go down two, you have a total of two numbers. Does that make sense? Start at 13, total of two numbers, 13, 12. So, for example, 13P4 would be start at 13, go down one every time, doing a total of four numbers. So 1, 2, 3, 4 numbers. There it is, whatever that equals. Does that make sense? You start at the first number, and the second number is the total number of numbers. I haven't showed you the C yet, but is that good so far for the P? So the first number is your starting number. The second number tells you how many numbers you're going to have. So that would be whatever that is. 13 times 12 times 11 times 10, 17160. So let's try the one right here, 13P3. So can you do 13P3? Why do I write C? 13P3. So that's going to be starting at 13. You go down one every time. It's like factorial, where you go down one every time. Three numbers. So whatever that is. That's 1716. We good? Now, last thing, the C. What does the C do, and how's that different? The C, 13C2, it starts out the same. So you start at 13, do two numbers, starts totally the same as the P, but here comes the difference. The C, I'm gonna use the word cut just to help you remember. You divide it by the second number factorial, or second number all the way down to 1. How about 2 times 1? So the C has a cut, has a dividing in there. So whatever that is, that would be 78. Does that make sense? Let's do the last one. We'll do a clicker and we'll be out of here. So last one, let's do part D, which is 13C3. Can you do that one? So that would be start at 13, do three numbers, right? Cut, divide by 3 all the way down to 1. The thing, it has to go all the way down to 1. That second number is on the bottom. It goes all the way down to 1. So if you multiply that in your calculator, 13 times 12 times 11, the top is 1716. The bottom is 6. You divide them and you get 286. And that's 13C3. All right, well, we didn't finish that. We didn't mean to. We'll stop right there.